Hello?
Hi, Engineer Ala. I think the voice is good. You can try to share your screen.
Okay. I think
You can try now.
okay. You should make me the host. Okay. But 1 minute, please.
Assalamu alaikum. Hi, everyone. My name is Abdullah Abdurrahman. I am training specialist in Reservoir Solutions Company. Just I would like to define Reservoir Solutions Company. Our company profile. Our Reservoir Solutions is a company specialized in providing technical studies and courses for oil and gas companies and professionals. Our company incorporates many professionals with diverse technical background related to oil and gas exploration and production. We are providing many services like technical reservoir studies, field development planning, reservoir static and dynamic modeling, economic feasibility studies, technical support for the academic researchers like PhD and master degrees students. Also, we are assisting in writing technical papers and publish it, technical petroleum courses by industry experts, and also we are providing mentorship programs. The next course that will be provided on 19th March, it will be case the hole and production logging. It will be 5 days hands-on experience using software. For the course content, the course content will start from the job design for production logging and end with how to interpret the data that will come from the field. By attending this course, you will enjoy lifetime access to recorded sessions. We will have also data sets to apply the theory and the practice on the software, application-based workshop. Also, the course material will be provided. You will have open discussion with the instructor. Also, at the end of the course, you will have certificate with online identification ID on our website. For the course content in general, by the end of the course, you will be able to understand the theory and the application for production logging tool, design BLT logging job program, perform interpretation for BLT log data using software. For example, some cases like an oil well producing from different intervals allocate water producing interval, water injection well, and gas condensate well. Also, you will know the tips and the tricks for the BLT log interpretation. You will understand the theory and application for the RST log. Select the optimal application mode for the RST log. Also, you will be able to do qualitative interpretation for the RST log. For the course content, I will share with you the link to download the course content and review it. If you are interested into that course, I will share also a link that you can register for the course. For our instructor for today's session, Engineer Ala Ragab. Engineer Ala Ragab is a senior reservoir engineer at Caron Petroleum Company in Egypt. He has bachelor's degree into petroleum engineering from Suez University. He has more than 15 years of experience in reservoir engineering applications like reservoir characterization, evaluation, and production surveillance. He has high experience regarding preparing of production logging field programs and also interpreting the logging data. For the webinar rules, you can ask your question into the Zoom chat. Please mute your microphone and camera. In case that you wanted to have a certificate for our today webinar, you can fill into the form that will be sent into the Zoom chat. For our upcoming webinars and events, you can join our Telegram channel and you will have our contacts. Thank you all, and Engineer Ala, you can start now.
Okay, thank you. Yeah. Okay, good afternoon, everyone. Today we'll have an overview for the production logging as all of the tools. Then we'll just have a focus on the BLT, as you are interested in the BLT as a production logging tool. Okay, starting with the production logging. Okay, we're talking about the definition and usage, then the applications of the production logging at all. Then we will focus on the BLT or the production logging tool. Firstly, for the definition and usage. If we're talking about the production logging, you said that is a log that will be run in the well is completed, even producer or injector. This is the traditionally meaning of the production logging. And now this meaning is expanded to include all the logs that have impact on the production, even during the drilling or completion of the well. For example, the cementing evaluation log, the CBL or cement pond log, you will run this log during the completion of the well. In some cases, if you have the surface section, you can run this during the drilling. But the cement itself have impact on the production. So we call this as a production log. As you know, if you have a problem in the cementing behind the casing, you will face problem in the production. Maybe you will lose your well at all if you have a problem in cement. So any log have impact in the production, we call it production log. So this meaning is expanded to include all the logs that can be run from the early stage of the well through all the life of the well till the end of the well with P&A or T&A. Okay. As usual, we didn't run any logs or something like this till you have a problem. Once you have a problem in the well, you're searching about what's the kind of log that will be run to solve this problem, and something like this. I think it's normal for all the companies to do this, but with the advanced stages in the production, like the secondary and tertiary recovery, you are in bad need for these logs for the monitoring of the distribution, especially in the secondary stage for the water flooding. If you are working with water flooding, it is essential to run the production logging tool to see what is the vertical distribution of the fluids in your injector to monitor your project, or to close monitoring for these fluids, and for monitoring of your sweep efficiency. And also, if you have modeling like Eclipse or simulation modeling, you should have a match between the actual distribution of these fluids with the model results. So from where you will get this actual vertical distribution? It is only from the PLT tools. Okay. Also for the completion, you know that the completion is vital for your well performance, even or for reservoir performance. So it is a method for evaluation of this completion is to run the production log to evaluate this completion. Okay, this is just a quick review for the definition and of the PLT. If we move of the production logging, if we moving to the applications, as we said, the production logging is from the early life of the well, starting from drilling to the end life of the well. So also the application will classify this application as during drilling and completion, and also for reservoir performance monitoring, and for the planning and evaluation of workover. For the drilling and completion, this is one of the application is to locate the lost circulation zone. This happened during drilling. Okay, if you have a high pressure, so low pressure zone or low pressure permeable zone, and this zone will have fluid, or will accept drilling fluid during the drilling, and we call this zone as a lost circulation zone. As you lose your drilling fluid during drilling in this zone, an application of the production logging is to locate which zone that have this lost circulation. In the opposite, the well kick or the blowout. If you have zone with higher pressure, and this zone will have a flow to the surface during drilling. We call it a kick or blowout. And also this application of the production logging is to how to locate this zone or the zone of or the source of blowout. Also for the top of cement, we're not talking about the evaluation. This is another application, is to evaluate the cement behind the casing, but it's another, this is another application is just to know the top of cement behind the casing, If you did the cementing job and you already the company man on the rig did the calculation to calculate the volume of the cement that will be pumped behind the casing. But maybe you have losses, or you have a zone behind this, the casing can accept cement. Okay? So maybe this design or the volume of cement is not sufficient to cover all the volume behind the casing. How we can know where is the top of cement behind the casing? This is also an application of the production logging, is to locate the top of cement behind the casing. This is the other application for the cement, is the cement quality itself. If you did the cementing job and you need to evaluate the cement or the bonding between the casing and the cement, and between the cement and the formation behind the casing, because you know that the poor cement behind the casing will cause a lot of problems. In some cases, you will lose the well as all, okay, due to the bad cement behind the casing. Okay, so this is application or means to evaluate the cement behind the casing, is to run the production logging, and we know that the cement bond log or the VDL for this application. Another application is to evaluate the gravel back quality. You know, in some cases you will run or place the gravel back behind the casing to prevent the production of cement. This is normal for some cases to run this gravel back, or to place this gravel backing behind the casing to prevent the cement production, the sand production. The placement of this gravel back is essential for the effectiveness of this gravel back. Maybe if you have a problem in the placement of this gravel back, it will be useless for preventing cement. How to know how to evaluate the placement of this gravel back, or the form of this placement? It will be done with also with the production log. This is a good application, is the perforation location or the perforation performance. We know that the perforation is the bus between the formation, or the bus that will provide the fluid from the formation to the well bore. Without the perforation, we will not produce. Okay, I think no one maybe didn't think about no one thinking about if we have or we perforate in wrong location. We said maybe no one faced this problem before. After perforation and you put the well on production, no production. But if you're looking at the log, yes, this is a good well. So based on the logging data, based on the pressure, this is a good well. I should have a very good production from this well. But after perforation and put the well on production, no production. Where is the problem? I think no one think about that. We perforate in the wrong location. I know that you did the perforation in efficient way. You run hole with the perforation and do correlation, the gamma ray correlation or correlation before the perforation. Before you perforate, you should have match, or you should have a correlation for the gamma ray between the open hole gamma ray and cased hole gamma ray. But maybe in some cases you have mismatch, or you have misleading for this correlation, and you will perforate in the wrong location. Also, to know where is the perforation, or to evaluate the perforation location, you will do this, or this is an application of the production logging. Also, the well treatment evaluation. In some wells or in some companies, this treatment will be vital or critical for production. For our company, for example, the hydraulic fracture is essential for production for us, and this is the most cost you have for the completion of the well. The hydraulic frac is a big cost in completion of the well. So to evaluate this treatment or this hydraulic fracture, it is also application of the production logging. The evaluation here, maybe you will not change or make a treat. If you have a problem for this treatment, maybe you will not make a remedy work for this well, but it will be effective for the next wells. You may change your design of the treatment for next wells. Okay, so how to evaluate this treatment? It is application of the production logging, and when we're talking about the hydraulic fracture or acid stimulation job, you will evaluate the region of, or the height, or the region in the formation that affected by this hydraulic fracture or with the acid treatment. Okay. The other application is the reservoir performance. The first and the main use is the measurement of the flow profile. This is the main application for the BLT tool in the well, is to get the flow profile. Is the flow rate versus depth. Just to get the flow rate versus depth, we call it the flow profile, and this is the main purpose for the BLT, and especially in the injector wells. When you have single phase, you will run just to get the flow rate versus depth. Another application is to evaluate if in producers you need to get now to differentiate between the types of fluids. So you will get versus depths the rate of each phase. If you have multi-phase, so you will get the rate for each phase, so you can determine the interval of isolation, which is zone that is the source of water and need to be isolated. Also, the reason for abnormal rate change. Maybe in your well, suddenly you will have a higher increase in the water cut and water production with a sudden decrease in the well head pressure, or if you have a producer, we will have increase in both water cut and well head pressure, higher well head pressure. So this is an indication of another source or another zone that share in your well. So to know what is the source of this higher water cut or high increase in the rate, we will run the ability to see or to evaluate the source for this higher water cut. Also, if you have a gas, maybe you have increase in the gas O ratio also. Also for the injector, maybe in some cases for injector wells, you may have a sudden increase in the injection rate and decrease in the wellhead injection pressure, which means of that you have another zone is open for injection, or you may have fractures or breakthrough in some zones that accepted more water due to breakthrough. So how to detect these zones or detect the source for this is applications of the production loop. Another application also for the performance is cooning. How to detect the depth of cooning? If you have water cooning like this, how to know the depths that the cone reach? This is also application of the production logging. We have here tools that just get the depths that the cone reach inside the well bore. Okay, if we're talking about the PLT tool, just get inside the well bore, and we have some tools that can get behind the casing to see the saturation behind the casing. Also for the gas, you can detect also the depths for the gas cooning. Also, if you have safe zone, or we call it cross flow, if you have downhole cross flow and you will lose production due to this, you have downhole cross flow like this from higher high pressure zone and another low pressure zone with high permeability, you will see cross flow like this and you will lose production due to this. So how to locate this safe zone, or how to know if I have cross flow or not? It is one of the application of the production loop. For the planning and evaluation of workovers, and this is for the mechanical problem, especially if you have any mechanical problem, like you have bad cement behind the casing and you have a channel like this behind the casing, or if you have hole in the tubing or with hole in the casing and you have loose in production like this, or like this if you have hole in the tubing also, and you have production from upper zone like this, maybe gas, maybe water, due to mechanical problems. How to locate these problems or to know these problems? It is using the production log. So at the end, for the application, you will use the production logging for verify the stimulation effectiveness and technique. And in some cases, we will change the technique of stimulation based on the results of production logging. As you know, there is a lot of techniques for the hydraulic fractures. You maybe use a technique in this well, and after the production and after evaluation, you will know that, or will see that this technique is not efficient or not suitable for this well or this field. So we can change or redesign for this technique for better result. Also, it is essential that, as we said, if we have a mechanical problem, so how to know the depths of this mechanical problem for bridge plug placement or pucker placement. So to know the depths or to locate the depths of the mechanical problem for isolation. Also to improve the completion, as we said, maybe not for the current well, but can be for the future wells. You can redesign or make change in the design for the future wells. Also, it is essential guide for the remedial workover designs, and also for the recompletion of unproductive offset wells. And especially for this point, we already make some recompletions based on the results of production logging. For example, may in your field you have some wells reach it to the economic limit based on the water cut or water production. You closed these wells according to the economic limit. This wells now is not economic, so we close these wells. Maybe after a while, using the production logging, you evaluate one well of these wells. You run maybe some sort of production logging and detect the source of water in these wells, and based on the results make isolation for this zone and make water shut off and reproduce the well again. And after put the well again in production, you see enhancement in the production, and the well come back and make become economic well. So you will review the offset wells based on the results of this well, and you can redo this job for the offset well and reproduce this wells again, or put this well again on production and make it productive wells. And we already have examples in our company for like this in some wells. After doing the production logging for all the closed wells and did the recompletion or did isolation water shut off based on the results, and the well come back again and put on production after the water shut off based on the results of the production log. This is for the application, especially for not the ability tool, but for all the production logs, which we can classify or put it in groups like this. This is, you can have cement evaluation logs like CBL, VDL, the ultrasonic logs for cement evaluation. So we call it the cement eval logs. You may have temperature log or temperature survey. In some cases, we can run only with the temperature tool as a log, and it will be useful and will answer your question for this well will be answered only with the temperature log. So we have a temperature log or temperature survey only. We have also the radioactive tracer log. This is like the BLT tool. We have the noise log, or especially now the spectral noise log. Also, we have the group of the corrosion measurement logs, or the integrity of integrity logs for the casing and the tubing, like the multi-fingering, like the electromagnetic tools. And we have the production logging tool, PLT, which is the main or the most used in the production logging. We have also the formation evaluation logs, and we call it production logs already, which we call it ABC. ABC, it means not alphabetic ABC, it analysis behind casing. ABC, it means analysis behind casing. We have a group of tools for the formation evaluation, like the reservoir saturation tool, the RST, like the cased hole formation resistivity, or the formation resistivity through casing. We can determine the resistivity of the formation behind the casing. We have the cased hole dynamic tester, which is like the MDT or RFT, but in casing. We have also a lot of tools can be run for the formation evaluation through casing. Like we have the cased hole porosity, we have lithology through casing. Okay. So this is for the application. Any question?
Yes, thank you, Engineer Hayat. We have some questions.
Okay.
We have a question. We can use downhole memory gauges for pressure and temperature survey. If you have formation damage, you can identify.
Yes. This is another way you can use. In some cases, or some applications that we said before here, can be done using another tools. We said here that this application can be done with the production logging, but also can be done with other tools. For example, if we're talking about the treatment, the frac or hydraulic fracture or the acid treatment, this can be evaluated using the well testing. if you did the well testing and make evaluation or make interpretation for the well testing, you will get from the interpretation of well testing the half length of the hydraulic fracture, and will give the effective the skin the negative skin due to the fracture. So you have evaluation for the hydraulic fracture. Okay, but we have another way also with the production logging, and it is essential to know what is the application or what you will get from the log. Okay, for especially for the treatment with the production logging, you just get the height of this treatment. Will not get skin or something like this, just get the height affected by the treatment. Okay, so as we said, this is application can be used. Maybe there is another application or another tools you can get these results with it. Okay.
Okay. We have another question. Does the tool show how much water, how much oil, how much gas is being produced? And if yes, how?
This is in the course. Yes. The answer is yes. Yes, how much is will get flow rate for each phase or for each fluid, for oil, for gas, for water. You will get Q of each phase versus depth.
Yes.
Okay.
We have another question. Can I use BLT for pressure surveys around the wellbore if I have formation damage, for example?
If you have formation damage, it is a tool to get information about this damage. So it will get you information about which formation have damage. Or if you have like base run before and now time lapse, you have a time lapse run, or after a while you have another run. So with comparing between these two runs, you will see which form have the damage. But as a quantitative interpretation for this damage, no, with the production logging.
Yeah. Another question. How do you differentiate between water channeling and cross flow using production logging?
Okay. For the production logging tools, it is easy using the spinner to know the flow or the cross flow. With the BLT tool, using the spinner or the BLT tool, it is easy to see this cross flow inside the wellbore. Okay, but the problem will be with the flow behind the casing, because if you run the BLT tool with the spinner only sees the flow inside the wellbore, so it will not. The spinner will not see the flow inside the wellbore, the flow behind the casing. The only tool in the BLT string or the BLT logging tool is the temperature. We run with the temperature tool in the string. So the temperature is the only tool that will see the flow behind the casing in this string. But we have another tools that can be see the flow behind the casing, not the production logging tool. Here you have also the radioactive tracer log can see the flow behind the casing. The noise log can see the flow behind the casing. Okay.
Okay. We have a question. BLT still can be used on wells which already run with artificial lift like sucker root pump?
Yes, yes, yes. Both. If you have ESP or Saka Road, we can run. But this is with special requirements or special downhole tools can be run for this purpose.
Okay.
And also we'll see this in the course. I will explain how to run the PLT tool and with artificial lift, especially if you have ESP or Saka Road.
Okay. The last question, have you seen any water recirculation case? If yes, what are the causes for this phenomenon?
Yeah, water recirculation. Okay, this can be happen especially in the high deviated wells. Okay, you can see this water recirculation. Okay, and this can be cause a problem in the interpretation. This will cause a problem in the interpretation to have this water recirculation inside the well bore. If you're talking about the water circulation inside the well bore, something like this, or you're thinking about what? This is your question about the water circulation inside the well bore, or?
I think that you can open your mic. I will ask him to open his mic.
Okay.
Hello.
Yes,
Hello?
you can. Yes.
Yeah, hi, Siddharth this side. So the question was like, have you seen any water recirculation case in your experience? And if yes, then what can be the reasons? Like why, how does this happen?
You're talking about the water circulation inside the well bore?
So yeah, so when we run a production log, you can see sometimes that the spinners, they read negative, even when we are
Yes.
running in a producer well.
Yeah,
So,
yeah.
So what can be the causes? Like one of the reason is, as you rightly said, that the deviation is very high, and then you can see the fallback.
Yeah, this can happen if you have highly deviated wells with high flow rate of water. In both, you have high deviation and high flow rate of water. This can be happen. You have circulation like this of water, and this can be edited or we can deal with it in the interpretation using the software for something like that. Yeah.
Okay, and the question regarding the differentiation between the water channeling and cross flow. So the point was like, of course, the spinner from spinner we can find out cross flow, because that's where the spinners can read the flow from the perforation coming out. But then if we have a small flow rate coming out, then how can we differentiate? Because then in that case, spinner won't be able to detect it. So then how can we differentiate using because temperature is the only tool in production log that can see behind the casing, right? So how can we differentiate using temperature between water channeling and cross flow if we have a very low flow coming out of the perforation that is beyond the threshold of our spinners?
Okay. If you have low rate, as you said, you're talking about low rate behind the casing, yes?
Yeah.
It will be a problem
even into the casing, even the flow rate, if it is lower into the casing, so our spinners won't be able to read it because it will be below the threshold, right? So if it is below the threshold, then how can we differentiate between channeling and cross flow?
Yeah, if it will be below the threshold of the spinner, you will not see it, or even inside the well bore due to this low flow rate. But maybe with higher speed, if you are doubt about something like this happened, we can increase the speed of the tool to see if there is a small flow risk. But the problem will be if you have a small rate behind the casing, and even so, if this flow behind the casing between two intervals very closer to each other, and maybe the difference in temperature between these two intervals is not bigger to be seen during the production with the temperature tool. You know, the temperature tool take a time to sense with the temperature, so maybe this cannot be seen during the movement of the tool with the temperature if the pressure differential between these two intervals is small. So there is another tools, not these, can be run to detect this, even with the low flow rate inside the well bore or behind the casing. We call it the water flow log. Okay.
Okay.
Call it water flow log. This log can see if there is a flow behind the casing, flow of water. So we call it water flow. So
All right.
if you doubt about the water flow behind the casing, and maybe the temperature differential between these two interval is small, so we can use this log is called the water flow log. The principle of this log depends on the theory of like the reservoir saturation tool, something like this. But this is
Basically the oxygen activation, right?
Yes, it's stationary. Yes, is oxygen activation.
All right.
So
So even if the quantity is small, we can detect using water flow log.
Yes,
That's
even it's small, you can detect this.
And we can also check for noise log, correct? If we want to see behind the casing, that can also detect very low rates.
The noise log, I think with the low rate, it will be not effective, because the noise log need higher rate to detect the flow behind the casing. It's based on the noise, so it need higher rate to have noise to be detected behind the casing. So also, if you have smaller rate, I think it will be not effective to use the noise log.
Okay, all right. Thanks a lot. Thanks a lot.
Okay, so no more questions in general, and I would like to thank you for this interesting session about PLT and its theory and application. Thank you again for your.
If you have just 5 minutes, I will I will need to emphasize here a point. Even after this discussion, you need to know what is the application, and besides this, you need to know the limitation of each tool, because maybe in some cases you will run with the wrong tool, or this tool will be useless for you. You will waste time, waste money, okay, and this tool will be useless for you because of the condition of your well or your case. It's not, this tool is not suitable for this. So it is essential to know what is the application and limitation of each tool, and based on this you will select, okay, the suitable tool for your case. Without this, you may lose money, lose time, without nothing, with nothing to be done. So here, as we said here, the first thing for your survey is the planning. The first is the planning to detect your objective firstly. What is the objective of running this tool? And you will have, based on your objective, it will be a guide for the selection of the logging tool. Okay, so based on your objective, you can select the suitable tool. So it's very, very important to know the application and limitation of the tools. Okay.
Okay, thank you.
Okay. Thanks. If you have, this is just a focus for the PLT as a production logging tool, which will be the main of the course. Probably for the monitoring evaluation, as we said like before. I need also to this is just a standard string for the PLT, and this is a tool in the standard string. Just run with the gamma ray, CCL, pressure, temperature, and the spinner, and also the tools for the multi-phase, if you need to differentiate between the oil and water and gas. You will end up with something like this as a tool view, and something also like this. And here I need to see a point, said something. The production logging tools, it is like the well testing. I think when we run the well testing, you just get what from the well testing. This is a question for you. What will the data we will get from the well test? The data we collect from the well test.
That indeed can answer into the Zoom chat.
Huh? Okay.
Surface rates, formation pressures.
Mm-hmm.
Skin factor.
Mm-hmm.
Average permeability.
Hello.
Hello. Yes.
Yes, sir.
All of this data that you write, it is after interpretation. The data just we collect from the well test. You run the gauges and just to collect the.
Hello.
Hello.
Yes, sir. Yes, sir.
Yes.
And you are asking what we'll get from the well testing. Actually, once we run the gauges up to the nipple and we set the gauges, sometimes we set for long survey like pressure build-up test and pressure fall-off test, like multi-rate test, isochronal test. It depends upon if it is injector well, we'll use the PO4 test. And if it is oil well, we use for depends upon choke size, right? So once we retrieve the gauge, we make some stops, like it depends upon production engineer requirement, and we'll get exact and pressure temperature of the well, and we can know the reservoir capacity, how much oil produce per day. Also we can know. So, and you mentioned here water or first oil. Actually, there is depends upon pressure and temperature. Using TVD depth, we can know what is inside, because there is gradient. If it is 0.12, 0.1112, it was gas. So first always it will be water, like gradient 0.45 to 0.55, it was water. Like after that, water plus oil mix. Then after that, it will be oil. If well shut in more than like 2, 3, 4 days, it will be separated. Water plus oil plus gas, then it will be gas.
Okay,
thank you.
Thanks. All of this data can be getted after interpretation. The only data that we collect from the job is the pressure, the pressure versus time, from the gauges with temperature. Also we have temperature gauge and the fixed rate on the surface. So just to collect the pressure and temperature versus time at constant rate. So this is what we exactly collect from the well test. But this is not the purpose of well test. I will not run the well test just to get pressure and temperature. We run to get the scan factor, to get the average permeability, to get the reservoir pressure, to get the, in some cases, the distance to the aquifer or the volume of the reservoir. All of these data just get it after interpretation. Before interpretation, you will have nothing. Just pressure and temperature versus time. This is also in the production log. Without interpretation, you will get nothing. It's just data, get it from the tool. With it, what can I do? Like the PLT, you will get not rate, you will get the reading of the spinner, which is the RPS versus time, versus depth, sorry. So you will get from the PLT RPS versus time, versus depth. So what I will do is RPS, I need the rate, not RPS. So this is the rule of interpretation, or the importance of interpretation to convert this data or to the tool data to what you need. This is using the interpretation. So interpretation is very important for us. So without interpretation, we'll get something like this from the tool. Just the reading of the spinner, the density tool, the flow view for the water and for the gas. It's curves or something like this. So where is the rate? I need the rate versus depth. So this is with the interpretation to get the, so after interpretation, you will get these results. And when we're talking about interpretation, we're talking about the role of engineer. Here, we have the importance of engineer that will do this interpretation. It's not like software user. I need interpretation to understand. I need an engineer to understand what he will do, how he will do this interpretation. Okay, so after interpretation, using this data, I said that the spinner data that you will get from the tool with RPS, and for the abilities, it's a concept for the interpretation that the velocity multiplies the area. The area, I can get it easily from the caliper, but what about the velocity, the fluid velocity? How can I get the fluid velocity from the RPS, or how I can convert the RPS to the fluid velocity? This is the rule of interpretation in the PLT to get something like this, to have this track, to get this track of flow rate. And as you see here, you have flow rate for every phase, water, for oil, for gas. Okay, thanks.
Okay. Thank you, Engineer Ala, for your time and effort. Actually, it was very, very interesting session for PLT, and we gained a lot of information about the application and also the theory for using PLT.
Okay, thanks.
Thank you. Also for the attendees, thank you for your time attending our session. And again, if you wanted to get a certificate for our session today, so you can fill into the certification form The link was sent now into the Zoom chat. Also, we will have a course for the case the whole and production logging, job design, and data interpretation. So if you wanted to register for that course, also you can review the course content. And I sent the link into the Zoom chat. And also, if you wanted to register for the upcoming course, you can register it through the link that was sent also in the Zoom chat. We will end our session after 5 minutes. You will have time to fill into the certification form and register for the upcoming course. Thank you again for everyone for your time, and hope you a good day, inshallah. Assalamu alaikum wa rahmatullah.
Thanks.